So here's another example on derivatives from first principles. We are given the function fx is equal to square root of x. So this is the inverse parabola. And we need to find the derivative for this function. Okay. Now to do that, we're going to use this formula, the limit as h approaches 0 for fx plus h minus fx divided by h. Okay. Fx is a function given on top, square root x. Fx plus h is a version of the same function but with a plus h next to the x. So I'm going to substitute the functions into my formula. So we have square root x plus h minus square root x. And this is all divided by h. Okay, now I'm going to use a trick that we learned from rationalizing the denominator. But now instead of rationalizing the denominator, we're going to be rationalizing the numerator. So I'm going to be multiplying the numerator by the conjugand. The conjugand is just a fancy word to say we have the same expression with opposite signs. So this is a minus b. I'm multiplying that by a plus b. So it's just the opposite sign. Okay, and we're dividing that by the exact same thing. I need to divide it by the exact same thing because I don't want to change the value of this here. Okay, and so when you divide something by the exact same thing, this is just 1. And when you multiply something with 1, you are not changing the value of that expression. Okay, so to continue, let's see what happens here, and we'll see why I'm using this conjugand. We have difference of squares, which means I'll just square that, and I'll square this, and leave the minus in the middle. So when you square this, we get rid of that square root, and when we square this, again, just get rid of the square root. And the denominator will have the h being multiplied by this square root plus that square root. Okay, so it's basically this h multiplied by that. What happens here is the x and the x cancels. So we are only left with h on top, and this is divided by the h at the bottom multiplied by those square roots. Okay, so you can kind of picture what's happening here. The h's cancel out once again, and so let me just erase this here because I want to continue on top. So I have the limit as h approach 0 of 1 on top divided by the square root x plus h plus the square root of x. So now I want to substitute h with 0. And so if I do that, this is x plus 0 under the square root plus square root x. So both of these is just square root x and square root x because 0 doesn't do anything. And so I just have 1 over square root x plus square root x, which is 2 square root x. And this is the answer for the derivative of that.